page. So we have these graphs. We drew the axes of symmetry. We talked about the maximums and minimums being called a vertex. We figured out that when they go up, the leading coefficient, or the number in front of the x squared, is positive. And when they go down, the leading coefficient, or the number in front of the x squared, is negative. So we have some highlighting that we can do on the next page. First thing, these are called quadratic functions. It has a y, an equal sign, and an x squared. This is the general form of a quadratic function. Very similar to the general form of a quadratic equation, but in chapter 3, instead of having a y, you had a 0, and you could solve it with factoring or completing the square or with the quadratic formula. Now that we put a y there, it creates a graph. And last semester in grade 10, you graphed y equals mx plus b. You learned how to graph straight lines. Now we're going to learn how to graph parabolas. How can we take this equation and draw the correct parabola that goes with it? So some characteristics of a parabola. The vertex is your maximum or your minimum point. And we talked about sometimes a parabola opens up, then it would have a minimum. Sometimes it opens down, then it would have a maximum. Another important thing is that parabolas are always symmetrical. So we have an axis of symmetry that cuts it right in half. And we use a dotted line because it's not actually part of the graph. It just helps us visualize the graph. So we draw a dotted line through the vertex that makes our axis of symmetry. And we talked about this in our original examples. When the coefficient of x squared is positive, it opens up. If the coefficient of x squared is negative, it opens down. And we're going to have to use some of these patterns we've noticed when we get to our first example and we try to graph. Now, domain, remember from grade 10, that's all of your x values. Since there are, you'll have to make sure you always put arrowheads on these graphs. When talking about the x values and looking at the graph, those arrows mean it goes up forever on the one that opens up, but it also goes to the left forever and to the right forever. And every single x value is possible. If you think about it from an algebra kind of way, is there any number you're not allowed to square? Can you square negative numbers? Can you square zeros? Can you square decimals? There's nothing you cannot square on your calculator, so that sets your domain up as everything. The range, though, the range depends on what your y value is. So here, if this point happened to be at, for example, 3, 1, we would say the range for this one is all the y values bigger than or equal to 1, because the 1 would be the minimum. It has every single x value, but the y values are always bigger than or equal to 1. So with that in mind, we can go to example 1. And we're going to want to graph this. And we have no shortcut methods yet. They're coming. Okay? Right now, about the only thing we can do is we can make a table of values. And maybe that will help us graph it. We can also, based on what we discovered already, can you tell that this one is going to open up? It's going to look like this, because the leading coefficient in front of the x squared is a positive 2. So that tells us at least that. we're going to want to try to find the axis of symmetry and the vertex. And all we've got right now is a table of values. Now, if I was doing a table of values and I wanted to make my mental math as easy as possible, what would be a really good number to start with? There's two like pretty good numbers, but I think there's like one is my favorite to start with. Any guesses what my favorite is?
One.
Second favorite. One is my second favorite. I'll put it second.
0.
0 is my favorite. That is wonderful mental math. Right? Because can you see pretty easily that if you plug in 0, you get -6. 1, 2, 3, 4, 5, 6. I can label that point. 0, -6. If I plug in 1, I have to do a little bit more math. It's going to be 1 squared is 1, times 2 is 2, plus 4 is 6. 6 minus 6 would be 0. Not too bad. Now finding those 2 points, and the fact that you know that it opens up, gives you a hint where your vertex is going to be. Is your vertex going to have a positive x value or a negative x value? You know that it opens up, right? Could it open up and have a vertex over here? No. The only way it could open up and have a vertex, I see that my vertex has to be negative. That's going to be important because I am guessing if I just let you pick the next number to try, you all would say 2. We did 0, we did 1, because it seemed natural that you would try 2 next. But 2 is not going to help us because we want to find the vertex, and I know that it's negative, so I'm actually going to try -1. And the key to finding the vertex is to find symmetry. So we're hoping that we get the same y value that we already got, because then we find symmetry. -1. -1 squared is +1, times 2 is 2. 2 minus 4 would be -2, minus 6, -8. Oh, I don't have symmetry yet. All right, but I can plug that point in. -1, -8. Okay. I would try -2 next. -2 squared is +4, times 2 would be 8, plus a -8 minus 6. Oh, look at this. We have symmetry. And as soon as you have symmetry, you know that your axis of symmetry has to be right between these two. Does it make sense that the only thing right between 0 and -2 would be -1? That gives us our axis of symmetry. And because it's symmetrical, if this one's at 1, 0, and that's 2 away from my axis of symmetry, does it make sense that your other x-intercept will be at -3, 0 in order for this to be symmetrical? And since this point is on your axis of symmetry, we know that -1, -8 is our vertex. So did we determine everything they wanted? Almost. We have our intercepts. -3, 0. These ones, we'll list them. These are our x-intercepts. -3, 0, and 1, 0. And then our y-intercept is 0, -6. So we found all of the intercepts. Do we have the coordinate of the vertex? We do. -1, -8. The equation of the axis of symmetry, x equals -1, it's always x equals, and it'll always be the x coordinate of your vertex. Remember from grade 10, vertical lines are always x equals lines, and the reason they're always x equals is because every single point on this dotted red line would have the same x coordinate. The x coordinate always equals -1, and that's why the equation is x equals -1. Our domain parabola, domain is everything. And our range depends on our vertex. Our vertex this time is a minimum, so our range is y is bigger than or equal to -8. You could also write that in interval notation. Do you remember set notation and interval notation from grade 10? You could use a square bracket to say 8 is included and then go to infinity. That says you're going from -8 all the way to infinity, up forever. So you have a choice to write it in set notation or interval notation. But if the question gives you, it could give it to you in either way, so you have to know how to understand them both. Okay, questions to practice are 4, 5, and 7.